Picture this, a 100-ton machine sitting on mud so soft you'd sink to your knees. Now watch it push 70 tons of dirt uphill without even slowing down. Impossible? That's what wheels would make it. But tracks? They turn physics into pure power. You've seen bulldozers dominate construction sites, but here's what most people miss. Those tracks aren't just about moving forward. They're solving 5 engineering problems at once. And by the end of this video, you'll never look at a bulldozer the same way again. A typical bulldozer weighs between 20 to 100 tons. The Caterpillar D11, one of the largest production bulldozers, weighs 115 tons. That's 80 cars stacked on top of each other. Now imagine putting all that weight on 4 wheels. Each wheel would have to support 25 to 30 tons. On soft ground, mud, or sand, those wheels would sink immediately, while the bulldozer would be stuck before it moved an inch. Tracks solve this through ground pressure distribution. Instead of 4 small contact points, tracks spread the weight across 40 to 60 square feet of surface area. Here's the mind-blowing part. A 50-ton bulldozer on tracks creates just 5 to 10 pounds per square inch of ground pressure. You, standing on 2 feet, create 12 to 15 psi. A 50-ton machine presses on the ground more gently than you do. That's why bulldozers don't sink. Wheels rely on friction between rubber and ground. On pavement, that works. On mud, loose dirt, or steep slopes, wheels spin uselessly. Tracks work like a continuous conveyor belt, constantly laying down fresh contact with the terrain. But here's the genius part. Bulldozer tracks have raised metal ridges called grousers. These grousers are 2 to 4 inches tall, spaced every 8 to 12 inches along the track. They work like cleats on a football shoe, digging into soft terrain and creating mechanical grip, not just friction. This lets bulldozers climb slopes up to 45 degrees, steep enough that you'd struggle to walk up it, and they do it while pushing massive loads. Bulldozers aren't just moving themselves, they're pushing massive amounts of material with that front blade. When a bulldozer pushes dirt, rocks, or debris, it creates enormous resistance. Imagine pushing 50 cars at once. That's the force we're talking about. Wheels would lose traction immediately. The contact patch where a tire touches ground is too small to handle that resistance. But tracks distribute that pushing force across the entire length of contact with the ground. When a bulldozer pushes, its weight presses down on the tracks, which press into the ground, creating a stable platform. A Caterpillar D11 can push over 70 tons of material in a single pass. That's 140,000 pounds, the equivalent of 50 cars simultaneously. The tracks turn the entire underside of the machine into one giant traction surface. Construction sites aren't smooth parking lots. 1 minute, solid dirt. The next minute, soft clay, then gravel, then mud, then rocky ground with debris everywhere. Tracks handle all of this without adjustment. Bulldozers can cross obstacles up to 3 feet tall. They can ford through water up to 5 feet deep. They operate on slopes where wheeled vehicles would tip over. A 4-wheel drive pickup truck can handle slopes up to 30 degrees before risking a tip. A bulldozer on tracks works safely on 45-degree slopes. Construction sites are brutal for equipment. Sharp rocks, broken concrete, metal rebar, nails, screws, debris that would shred rubber tires in minutes. Bulldozer tracks are built for this punishment. Each track has 40 to 50 individual steel links connected by hardened steel pins. The track shoes that contact the ground are made from manganese steel, one of the toughest materials in construction equipment. These tracks roll over sharp rocks, broken glass, metal debris without serious damage. And here's the advantage. If a track gets damaged, you replace individual links. A damaged link can be swapped in 30 minutes to an hour. Compare that to a large industrial tire, which costs $5,000 to $15,000 to replace. Now, tracks aren't perfect. They have one major downside: speed. A typical bulldozer maxes out at 6 to 10 miles per hour. That's slower than a jogging pace. Why? Tracks create more friction with the ground than wheels. That continuous contact providing great traction also creates resistance-limiting speed. A wheeled loader travels at 25 to 40 miles per hour. A dump truck hits 60 miles per hour or more. But bulldozers aren't built for speed. They're built for power, stability, and traction in the worst conditions. When you're pushing 70 tons of dirt through mud on a 30-degree slope, speed isn't the priority. Not sinking, not slipping, not tipping over. Those are the priorities. So why do bulldozers have tracks instead of wheels? Because tracks distribute weight over 40 to 60 square feet, creating ground pressure as low as 5 psi, less than a person standing, preventing sinking in soft terrain. Because tracks provide continuous traction with metal grousers that dig into ground, allowing bulldozers to climb 45-degree slopes while pushing massive loads. Because tracks turn the entire underside into one giant traction surface, distributing forces that move 70 tons of material without slipping. Because tracks handle every terrain, mud, sand, gravel, rock, water, and roll over 3-foot obstacles that stop wheeled vehicles. Because steel tracks are nearly indestructible, rolling over sharp debris that would shred tires, with individual links replaceable instead of the entire track. The trade-off is speed, 6 to 10 miles per hour versus 25 to 40 miles per hour for wheeled equipment. But when you're moving 100 tons of machine and pushing 70 tons of dirt through mud on a steep slope, speed isn't the priority. Traction, stability, and raw pushing power are. Next time you see a bulldozer at a construction site, watch how it moves. Notice how it doesn't sink, doesn't slip, doesn't hesitate, even in conditions that would stop any wheeled vehicle cold. That's not just brute force. That's over a century of engineering refinement, all built into those continuous steel tracks.